Hi, I'm Duncan Maitland. I'm an associate professor in the Department of Biomedical Engineering at Texas A&M University. The motivating factor that drives me is the ability to take diseases or clinical problems that don't have solutions or don't have good solutions and develop technologies from whiteboard concept and take it into humans. The way that motivation, the motivation to impact healthcare, translates into the research that's in my lab is through attacking clinical problems, bringing in whatever technologies we need. That has resulted in kind of a platform technology, if you will, which is the shape memory polymers. And I have been applying shape memory polymers since 1995 to treating stroke. We conceptualized in 1998 a shape memory polymer foam, open-celled foam, that could be compressed, expand by 100x volume, and be placed in that aneurysm, triggered to expand, and it would create a network of microclots that would far more effectively fill and embolize the aneurysm. The acute measure of a treated aneurysm is if that aneurysm gets filled with a blood clot. And current devices put in about 20 to 30% of the volume with metal. These are metal wires, coils is what they're called. And our device puts in this single foam that expands, clots the entire aneurysm, and that blood clot is far more, for our device, the blood clot is supported in all dimensions throughout the entire volume of the aneurysm with the shape memory polymer foam. The shape memory polymer foams are superior because they clot better acutely, they rapidly endothelialize and close off that neck of the aneurysm from flow, and where the metal coils have 40% reoccurrence of recanalization or the aneurysm reforming, our foams encourage very healthy response from the tissue, and you get live, vibrant cells throughout the healed aneurysm. We've shown that we get these better, equivalent or better responses both acutely and, more importantly, chronically in the treatment of aneurysms. And so we've proved out that these shape memory polymer foams can be delivered through all the logistics of, they can be delivered, they work, the clinicians are kind of happy with the design, how they feel relative to current devices, all these kinds of things. But the baseline technology is going to open up applications all over the body, both in the vasculature and out. We have applications in the cardiovasculature and the peripheral vasculature, treating other types of aneurysms, treating types of aneurysms that nobody could treat right now. I think this is the technology platform that can lead to much better treatment. In many cases, you want to actually, any place where you want to block flow, there's cancers, there's malformations of arteries and veins that you want to block up. These foams have lots of applications in those directions.